Hello everyone. What you're seeing right now is the first software prototype for my senior design project, Fight Flight. Over the next several weeks I'll be developing this software to its final form, but in this video I will show the progress I have made up until now. Fight Flight is two drones playing laser tag with each other. So we're going to build two drones, each with 100 health, and they will be shooting lasers at each other. And every time a drone gets hit by a laser, they will lose a life. And there'll be different weapons, each doing different amounts of damage, so either 25 or 50. And the first drone to lose all of their health will lose, and the opposing drone would be the winner. The Fight Flight team consists of 4 people, me and 3 of my friends. For this project, my friends mainly work on the hardware, while I work on the software. Our project consists of 2 main parts. The first is the drones, which will have a custom flight controller, and the software, which will be run on 2 separate computers, one for each drone. The computers will receive the video transmission and telemetry and use it to make a cohesive game. Since I am mainly working on the software for this project, my work revolves around the second main aspect. While it would be really cool to have the drones shoot lasers at each other using laser diodes, my teammates and I don't want to get arrested for accidentally shooting a plane or a car. So instead, we're going to be shooting digital lasers at the drone and use computer vision to detect if the opposing drone has been hit or not. More specifically, I'm using OpenCV, which is a library for real-time computer vision to detect the drone. This is a test chassis that I found on Thingiverse and printed on my Ender 3 printer, as my teammates are currently working on the actual chassis. But if you haven't noticed already, the chassis is pink, which is actually by design. Using OpenCV in Python, we can detect the drone by looking for the color pink, since we found that in most settings this color is uncommon. We scan the entire screen pixel by pixel and look for the color pink. The program then will choose the largest blob of pink and select that as the drone. But what if there's another pink object that is larger than the drone in frame? To combat this, we will also be using the opposing drone's GPS coordinates to ensure that what OpenCV thinks is the drone is actually the drone. In practice, the program can isolate the drone pretty well. This comprehensive approach not only ensures a robust and accurate identification process, but also fortifies the system against potential false positive, guaranteeing that the recognized ping object is indeed the targeted drone. It could even detect the drone from a long distance as seen here, which is over 20 feet away. Now that the drone detection code has been completed, it's now time to move on to the game aspect of the project. Since all of my code so far was in Python, the game also needed to be in Python, which was something I've never done before. But I eventually started to use pygame, which is a free and open source library for the development of video games. After some time, I managed to get this prototype up and running, which is the same application as the beginning of the video. The health bar of the 2 drones is at the top, as well as the fire button at the bottom. This button won't be present on the final version of the game, as the actual button will be on the controllers, but it's here for now so I can test the program properly. When the fire button is pressed, digital lasers will be shooting from the middle of the drone and will go straight. So for now, if the opposing drone is in the center of the screen and the fire button is pressed, it would represent a hit on that drone. With the ability to detect a hit, we now need a way to send that fact that the drone got hit to the second computer, and vice versa. To do this, we are using WebSockets, which allow us to send and receive data between computers. This can be done wirelessly, but since we plan on flying these drones in places where an internet connection is not present, like in the middle of a field, we are connecting the 2 laptops with an Ethernet cable. To get the communication working, we have a server script that runs on one laptop and then the game which runs on both laptops. Once both laptops are connected to the server, the game starts, and hit data will be sent back and forth. Telemetry data will also be sent via this method as well. When we put all of the components together, we get to this initial prototype. As you can see, when the opposing drone is in the center of the screen and a laser is fired, the health of the opposing drone goes down and it's reflected on both computers. Nothing happens when the health reaches 0, but it's a prototype and is only meant to show the concept of the project. In the upcoming weeks, I plan on adding additional features to the game, like a reticle, telemetry data, a mini-map, and different weapon types. I also have a MetaQuest 3, and one of my teammates has a MetaQuest 2, so if there's enough time, I want to make it so that those headsets act like an FPV headset for more immersion. I put all of the code that I have written so far on my GitHub, and will continue to update it as I work on the project for the next several weeks. Finally, I want to say thank you for watching, and have a great rest of your day.